Hello, math lovers, math enthusiasts, and math contest junkies. Welcome, welcome. It's Root Beer here. And for the next 4 videos, we're going to take a look at the 2007 Fryer contest. So that's the written contest put out for the grade 9 level of mathematics education, and it's put out every year by the University of Waterloo. So let's jump right in and take a look at question number 1. All right. So we have our Fryer here. Question 1. Squares measuring 1 by 1 are arranged to form the following sequence of rectangles. So we have rectangle 1, rectangle 2, rectangle 3, and we have a 2 by 3, a 3 by 5, and a 4 by 7. Many more rectangles are drawn, with each rectangle having 1 more row and 2 more columns than the previous rectangle. Okay. A part. How many 1 by 1 squares would there be in rectangle 4? Explain how you obtained your answer. Alright. Very first part of the very first question, I say probably the easiest thing to do to get a better handle on these rectangles is perhaps to draw out rectangle number 4 and then go from there. So to get rectangle 4 from rectangle 3, we just add a row and 2 columns. So how about we draw rectangle 3 right now? Doesn't have to be super exact. We want 4 rows. And 1, 2, 3. Oh, we need another row, silly me. 4, 5, 6, and lastly 7. So rectangle 3 was a 4 by 7. Okay. So what are we going to add? Let's pick out what we're going to draw with. How about the red? Well, the pinky red. So we added 1 more row. We can do that either top or bottom. Doesn't really matter where. We're going to have to extend these rows a little bit. I should probably be using the grid paper a little more than I do, but doesn't really matter. I always think the best thing on contests is to bring your own grid paper. That way you are not stuck in a situation like this, drawing a particularly bad picture. Although if the picture represents what you need to work with, it doesn't matter how lopsided or crummy or not to scale it is, as long as you get the information you need to solve the question out of it. So there we go. We added 2 columns and 1 row. And if we know the dimensions of our rectangle, we then know how many 1 by 1 squares make it up. And that's exactly what we were asked for. And we explained how we got it. We even drew rectangle 4 from rectangle 3. Okay. So that's A part. The answer is 45. B. Determine the perimeter of rectangle 4. Explain how you obtained your answer. Okay, that's not that hard. We already have rectangle 4. We drew it in the previous question. Alright, we add up 5, 9, 5, 9. Or if you wanted to, you could probably use a formula for the perimeter of a rectangle. Doesn't particularly matter. So that's 2 14, so that's going to be 28. And that's our answer for B part. Very simple, thanks to the work we already did in A part. Okay, C. Determine the perimeter of rectangle 7. Explain how you got your answer. Alright. And if we look ahead at D part, rectangle N has a perimeter of 178, determine N. So it might be nice to develop a formula in terms of what rectangle number we're talking about for the perimeter. So if we call that rectangle number N, that'll really help us for D part, but we're using a very general. N can be any number. It could be 1, 2, 3, 4, doesn't matter. So rectangle N has N plus 1 rows. Remember, rectangle 1 had 2 rows, rectangle 2 had 3 rows, rectangle 4 had 5 rows, rectangle 3 had 4 rows. Sorry, I went out of order there. So this is not that hard to see. How many columns does it have? Okay, well, we had 9 columns with 4. We had 7 columns with 3. We had 3 columns with 1, and we had 5 columns with 2. Now, it doesn't take too long to realize you're going to have 2n plus 1 columns. If this were a later question, we would offer more justification for it, but it's question number 1 on the easiest of the written contests, the grade 9 contest, so I would say it's fair to just make this observation here. Also remember, it's a 4-part question. Each question is worth 10 marks, so at best this part is going to be worth 3. So we don't need a lengthy induction argument or anything for the formulas for rows and columns. Just simple pattern recognition will do. This is at most worth a mark. Okay. We get n plus 1 plus 2n plus 1 plus n plus 1 plus 2n plus 1. Okay, that gives us 6n's plus 4. Something appears to be... No, I guess that's right. I was looking over at this 45 and thought, well, this number here is going to be always even. How did I get 45 over here? But 45 is the area. So we have 28 here. So rectangle 4, 6 times 4 is 24, plus 4 is 28. So this certainly works. So for C part, we want the perimeter of rectangle 7. Six times 7 plus 4, that's 42, plus 4. You can either do that on your calculator or you just know 6 times 7 is 42. And you get a final answer of 46. Now for D part, let's just go back and check what D part said. Rectangle N has a perimeter of 178. Determine N. Explain how you obtained your answer. Well, we just need to make use of the formula we already developed on the previous page. And that explains how we obtained it. So 178 is the perimeter we're given. We just don't know what rectangle number it is. It's rectangle N, but we want to find out what N is. So we can rearrange. 6N is 178 minus 4, which is 174. So then N is going to be 174 over 6. And if we plug that in on the calculator, we get 29. So rectangle 29 has a perimeter of 178. Okay. So notice that by looking ahead, when we read C, B, we encountered perimeter in B, and then we encountered it again in C, and we looked ahead and we saw, oh, D is also going to involve perimeter. So perimeter is a very important thing. It might be a good idea, it might save us time if we develop a formula for perimeter, and that's something you sort of need to watch out for. It's always a good idea to read the whole question before you even do it. That way, while you're doing the easy parts, part A and B, they're usually introducing you to the concepts, you can be thinking ahead to, okay, what patterns am I recognizing? What patterns might I need to do parts C and D, the really hard parts that will involve theories and general formulas that I need to develop? So it's always a good idea to read the whole question before you do anything, before you embark on it. And so, yeah, there's not a whole lot else to say about question 1. It's a nice little 4-part question. And that starts us off on the journey that is the 2007 Fryer paper. So hopefully you guys will join me for the next ones. And don't forget, if you click the link below, you can get a copy of this contest and try the questions for yourself. Okay? But I'll see you guys next time for question number 2.